Okay, our topic today is the language of algebra. Now, as you may understand, mathematics is in some ways its own language, and because of that it has its own vocabulary. So we have several terms, several words, several pieces of language that we need to go through today. The first one is the term pronumeral. Now, pronumeral may be something you're familiar with. If you're familiar from English with the term pronoun, a pronoun takes the place, it's the word that takes the place of a noun. A pronumeral is a letter that takes the place of a number. Now, we use those quite frequently in algebra just to help us along with our process, which you'll understand as we go along. A variable is a special kind of a pronumeral. Sometimes pronumerals can mean the same number all the time, but sometimes they don't. Sometimes they change. We have something that we've written and maybe it has an x in it, and maybe right now that x equals 2, but sometimes maybe that x equals 20 or 3.5 or 1/2. It can mean a lot of different things. So that's a particular kind of pronumeral that we call a variable. An expression is a combination of pronumerals, numbers, and various mathematical operators: add, subtract, multiply, divide. Okay? It doesn't have to have all of those things, but it can have a variety of them. So, for example, something like 3a is an expression. It's a number and a pronumeral, and they're multiplied together, 3 times a. Maybe we have something like 4b plus 6. We've got numbers and a pronumeral and some addition and some multiplication. Maybe we have something like just x. Now, there's no mathematical operators there, but it's just a pronumeral. That can be an expression. Okay? Now, within expressions, I'm going to use this example. This is an expression: 4a plus b minus 12c plus 5. Within an expression are terms. Terms are typically separated by addition and subtraction because they don't usually include addition and subtractions. Pronumerals, numerals, and multiplication and division make up terms. So, for example, in this expression, we have 4 terms. We have 4a, we have b, we have 12c, and we have 5. Okay? 4 separate terms divided by the addition, the subtraction, the addition. Those divide up the terms. Now, a constant term is a special kind of term. It's a term that doesn't change. It's not variable. Okay? So here, this has a variable or pronumeral in it. So does this. So does this. But the 5 is not. Regardless of what we do, the 5 is still going to be 5. That's called a constant term. It's a term that is only a number, generally speaking. And a coefficient is a term that we use to refer to the number that is in front of a pronumeral in any given term. So we have terms here. We'll use 4a as an example. The coefficient of 4a is the 4. Okay? That's the coefficient. Now, sometimes we don't have a number that's obviously written. For example, here's a term. It just says b. What's the coefficient? The coefficient, if there isn't 1 there, is assumed to be 1. And the reason is because we could write this 1b if we wanted to. There's just 1b there. Okay? Now, the other sort of special case is if we have something that is subtracted, like this one. It's a term that's subtracted from other terms. And in that case, the coefficient here you'd think would be 12, and it is 12, but it has to have a minus in the front of it. The coefficient is minus 12. Okay? Those are the major sort of vocabulary things. These 4 terms are about operations that we do. Some of them you've probably heard before, some you probably have not. When we talk about a sum, that means that we're adding. So for example, if I said, what is the sum of 2 and 3? The sum of 2 and 3 would be 5. We've added those 2 numbers together. Difference refers to subtraction or minus. So if I said, what is the difference between 8 and 5? That means 8, take away or subtract or minus 5. 8 minus 5 is 3. The difference of 8 and 5 is 3. Product is multiplication or times. So if I want to know what the product of 3 and 5 is, that means 3 times 5. The product of 3 and 5 is 15. Quotient, probably a word you haven't heard before. Quotient, of course, means divide. That's the only thing we have left. So if I said, what is the quotient of 6 and 2, that means I want to say 6 divided by 2. The quotient of 6 and 2 is 3. 6 divided by 2 is 3. Okay? Now, also there's a couple of conventions or typical things that we do in mathematics when we're talking about algebra. They're not crucial, but they're the way we typically do things to make it simpler for us to do what we're trying to accomplish. So, those are, if we're doing something like 4 times A, we typically don't write the times sign. So we have 4 times A, we would say instead 4A. That's what that means. Or we could do it if we had something like just a couple of pronumerals multiplied together, then we would say AB, A times B. Similarly, but slightly different, it's related to this, if we have something like A times A, something multiplied by itself, this is what we call a square. So if we had a square that was 2 on a side and 2 on a side, we'd multiply those together, get the area of the square. A times A would say A squared. Okay? And then the last convention that we typically use in algebra is we don't use division signs very often. So if we wanted to say something like 4 divided by A, we would write that as 4 over A. We would write it like a fraction. 4 over A. We can do that with 2 pronumerals. Let's say we had A divided by B. Instead, we would typically write that as A divided by, or A over B. We can even do it with just numbers. 2 divided by 3, we write as 2 over 3, or 2 divided by 3, or 2/3. Now, we've talked about how these work. Let me give you another example. Let's say we want to, because what we're often doing when we talk about algebra is trying to turn words into numbers or into mathematical expressions. So we're going to use some examples here. The first one, the sum of 3 and 4. The key word in this sentence, or in this statement, is the word sum. Because sum tells us what are we going to do. If we have sum, then we're going to, remember over here, we're going to add. So when we write this, we say the sum of 3 and k, 3 plus, or 3 added to, k. 3 and k. The next one is similar to that, the product of m and 7, we're going to multiply those together. M and 7, we're going to multiply m times 7. But if you remember what I said over here, we typically in algebra, when we're doing times, we don't actually write the times symbol. So what we'd write instead is 7m, because we also put the number before the pronumeral. Always the number before the pronumeral. So we could say m7, but that would actually be confusing with some other ideas. So we write the number first, 7m. Okay, now this one is just a little bit harder. It doesn't have any of our magic words, sum, difference, product, or quotient in it, but it does have this word, added. So again, that means we're going to add. So we're saying 5 is added to something else, 1/2 of k. So that means we're going to have plus 5, because we're going to add 5. Now, the word of, almost always, not always, but almost always in mathematics means times. So when we say 1/2 of k, 1/2 times k. So what we can say here is 1/2 times k. Now if you think that's a little bit confusing looking to write it like that, you're right. And so what we typically would do, remember, we don't usually write the times in, so the better way to write this would be 1/2 times k, 1/2 k, plus 5. Now, if you want to think a little bit more deeply about this, the other way that we can write this, and this, if you're a little confused about this, it's not imperative that you know it right now. The other way we could write this is k over 2, that's the same as 1/2 k, plus 5. And if you think about that, it makes some sense. If I said, what is 1/2 of 6? That's 3. It's the same thing as 6 divided by 3. But we'll cover that in more detail later. The last example here, and we have one of our magic words again, sum. The sum of A and B. So we need A plus B. Now, we also have this phrase on the end, is doubled. Okay, is doubled. And that's sort of a casual way of saying what? What is doubled means? It means multiply by 2. So I need to multiply A and B times 2, and not just A, not just B, but the whole thing. So I have to put brackets in, times 2. But remember what I said up here? Up here, when we multiply by a number, we usually put the number in the front, and we drop the times sign. Remember? So instead of m times 7, we say 7m. The same is true here. The better way to write this is 2 times A plus B. It's the same thing as this, but it's a little more consistent with the conventions we usually use. And that is the language of algebra.